All right, well, thanks everybody for making some time today. I'm Kevin Cools with Forward Networks, and we're going to talk about, the buzzword out there. A lot of people are talking about zero trust, right? How can we get there? How can we assure access to applications, but only that given access? There's a lot of great products out there that are going to help us get there. But then there's that question, how do I know when I'm there? How do I know each step along the way that I'm making progress? That's where, specifically on the network side, we leverage a digital twin, mathematical model, to get us to that step, to understand all those permutations of traffic through our environment so we can establish some level of confidence in this zero trust solution. We all know networking is hard. We've been doing it a long time. That's nothing new. But there's always the second step of that equation of we also have to get past another hurdle of compliance, of accreditation, of change control. And getting through that has always been a challenge of really trust of the security team and the operations team of the engineering folks. So how can we help provide them tangible evidence of application reachability and isolation and protection? That's where zero trust comes in. We're trying to say, well, here's a way where we can show the applications are only reachable to the right people at the right time, from the right device. It's very optimistic, if you will. And there's no one solution to get us there. There's no, I buy that fancy application firewall or out there and get an overlay technology that's going to provide that policy enforcement. There's a lot of steps along the way. And in fact, it gets a lot uglier when you start looking at the weeds of how do we implement zero trust. So this is all of those different silos as per the ATARC consortium that's focusing on providing zero trust for a network, for our government employees and through our different organizations. If we dig into that, how are we establishing any progress? We can't just run out and focus on, we got problems today in front of us of trying to establish progress. We have deadlines this month, next month, the month after that are coming down from executive orders to provide some evidence of our progress. So how do we get there? What's missing from this solution? What's missing to help us make that progress? Well, we have, how is our network behaving? Do we understand, other than what's in our heads, how this network is forwarding traffic? And then on the other side, do we understand from a security perspective what traffic can go from place in the network A to place in the network B, to have that flexibility to show segmentation, whether micro or macro? And at the lowest level, just can we understand what's on the network? Asset management, users who are connected to the network, there's a lot of low-hanging fruit, at least with some theme, to understand who's on the network, what's there already. And so we can understand that identity and the devices and the data that are already there. There we go. So how can we take that leap? We've done this a few times before, right? If our first responders, they don't open up good old Rand McNally when they're trying to track down where they need to be to respond to an incident. No, they've got GPS that can tell them all the different ways they could possibly get from point to A to B. There's a digital twin of the Earth represented in that GPS map. And also for the internet. We don't, click our way through the internet anymore, right? We have web crawlers that index all of that data out there and present us with search optimization so we can find what we're looking for rapidly and not burn cycles. You put those two together from the perspective of your network. Now I can understand all the different permutations of traffic in my network, but also I have all this configuration and state indexed and readily accessible to give me two things: instant access to my data, but leveraging that same data, now I can define correctness. I can help establish compliance, create compliance rules based on my zero trust objectives. And Zero Trust is a new term for what we've had all along. We've called it segmentation. We've called it firewall rules. We've called it network protection. We've called it all these different flavors over the years, current version of that whole title. And through a digital twin, there's a couple of definitions I want to focus on, right? When I define digital twin, it's a behaviorally accurate software copy of the thing. In this case, a network, right? It includes a couple of key components. There's the map, which is great, right? There's an understanding of what's there. That's the table stakes. That's getting us started, right? The key is being able to understand all of the potential traffic, to go through what-if scenarios within that environment. What if I change this ACL over here? What traffic is allowed and what is denied? What if I were to add a different compliance rule? What impact will that have to application reachability and isolation as well? And to do this at scale, right? We're not talking about small networks. We're talking about massive networks, whether they're federal networks or commercial. Whether you're a big bank, whether you're a large federal agency, or if you're even a deployable a group of folks within our military. All of these come down to large, agile, flexible, but also brittle at the same time networks. So now we can look at that digital twin against that eye chart that ATAR provided us with. You can see highlighted, these are places where that digital twin can help us execute. The yellow ones are directly, the blue ones are indirect, right? And I'm not going to read through them individually. We're going to cover a couple of key ones, right? And focus on those key assets. So we talk about the device and the endpoint side. Just simply knowing what is out there, right? So if we think about digital twin for the network, it's going to collect all the configuration and state. So that means I have ARP tables. I've got MAC address tables. If the network doesn't know about it, it's not there, right? So from all of that information, if I aggregate that, I know absolutely every endpoint in my network. I could use that a couple different ways. I could use that as source for my ACAS scanning. I could use that as a group of hosts or an object with which to translate all of my, or that those applications are reachable from those given hosts. A couple different angles to look with that. And also for intelligent response, to know, okay, now if I know where all my hosts are, and if I understand my traffic permutations, I can know all the different possible blast radius of those. So if we dig into visibility, right? One key one to focus on here is that we're collecting configuration and state. It's all text, right? So it doesn't matter if it's one collection, or in this case, 3 of my underlay, black network, my gray network, and my high side, my classified. I can take those 3 snapshots and actually merge them together to provide the true digital twin, because that's the reality. The network is all of those pieces if I'm looking at a CSFC environment. It's not just what can I ping or what can I SSH to or what can I gather NetFlow from. It's the entire network together. And then I can define rules around compliance. So for example, I never want the red side to be able to talk directly to a black or gray. Makes perfect sense. My zero trust boundary there is avoiding data leakage. Also looking at all that configuration and state and visibility, I can define compliance as how we have traditionally. Things like sticks, things like routing table correctness. I want to assure that peer devices have the same routing table, right? If we think about the STIGs themselves, their boundary condition is around the configuration only. There's a lot more data that we can take advantage of when we think about the routing table via IPv4 or v6 or multicast routing. That presents the reality of what that network is ready to forward. So we want to make sure that redundant devices are actually providing redundancy and there isn't a mistake there. Looking at the network side specifically, there's a lot of places that we can address with a digital twin. For example, if we're looking at like some of the specific items within the EO, AC4, I want to make sure that specific traffic patterns are available. So I can go through my checklist of, all right, I only want to allow my database to my back end or my user to my front end. I can create these rules that persist within my twin and will alert me when there's a configuration or a state that will provide a traffic pattern that defies those rules. In addition, so now I'll have a way to create alerts and to take action upon and notify before there's a breach, notify before there's an incident. Likewise, we can make more generic requests of, well, if I'm coming from an access switch, that's most likely user, talking through a data center switch, most likely an application behind there, is there any way to get from switch to data center switch without going through a firewall? Those are types of rules that I can set that go well beyond anything you can comply with or a configuration compliance. This is about network function. Is it doing what it needs to do? So this is where I talked about, we've got great partners that provide those L7 firewalls, those application firewalls, but it doesn't do us a lot of good if the traffic is actually diverting around them. Likewise, on the application side, how can we support those mandates of those different pillars? We talk about everybody starts with a spreadsheet kind of like this when they build a network. Who needs to talk to who? And then we deploy the network, and this is thrown out the window, right? But if we understand all the different permutations of traffic, it can persist. We can be aware any day, any time, what places in the network can talk to other places in the network on which protocols. We can see in this case, specifically through the view of the digital twin with forward networks, I can see gray is where there's no route. You can't get there if you tried. Red is entirely blocked with a firewall. Yellow means partial connectivity. So there's certain ports, you can click on that and dig deeper to know what IPs are allowed, sources and destinations. So you can really keep a grasp on what does my micro and macro segmentation look like. That's a key requirement as we're moving on to whatever we want to call our security journey, now called Zero Trust. Likewise, from the perspective of that visibility pillar, there's a couple of the key ones we can look at around continuous monitoring and auditing. We can say, well, we're going to gather configuration and state of those devices, and we're going to look for compliance, not just, again, with the STIGs, but functional compliance. We build a query, if you will, querying a network like a database, so you can get in front of these issues before they rear their ugly head. Well, I've got a device with NTP out of sync. It's not a config. It's not going to be caught with the STIGs. It's a functional requirement. I can resolve that by looking at my state of my network devices. I query that as I collect that information regularly. Likewise, maybe I have someone created a too permissive of a rule within an ACL. I can catch that as well and then say, oh, I want to remediate that. Or I can see there are two disparate tenants that should never touch each other. Oh, I see routes being leaked and advertised across. These are all things that we all see or could see with our subject matter experts. Doing show commands, logging into devices. But realistically, they can't do it 24/7. Realistically, we need them to do more interesting architectural work. We need to leverage the tools in front of us to save them time, so we can make our Tier 1 and Tier 2 operators more valuable. Give them tools that's going to make them more powerful so they don't just kick tickets up to those Tier 3 and Tier 4 individuals. And if we're made aware of these issues, we can resolve them. We can have auto-remediation. We can build rules within that to say, when I see, if X, then Y. Hundreds of these queries are built into the platform. So instead of having that annual, painful check, turn that into a daily occurrence. Another one around that more specifically, if we're looking at vulnerabilities, it's not rocket science. We know what versions of code we have running on devices. Usually it's a data call. Say, okay, a new vulnerability came out. We're going to hear from our security engineers, I need to know who's got routers and switches and firewalls vulnerable to this particular CVE that just came out. On top of that, it's not just, is it that version of code? That's data call number one. Data call number two, well, did they actually expose the vulnerability? Is the configuration knob enabled? All right, well, now the network engineer, security engineer is going to do another thing. Got to look into that vulnerability and see if that's turned on or not. And then the third thing, based on that mathematical model, we can present what are all the possible sources that can then reach that device to take advantage of that vulnerability. So 3 data calls that would take hours of your subject matter experts. They're doing it regularly because these vulnerabilities come out all the time, all baked into the platform, all available via API or UI for the security operators so they don't need to bother those engineers and security engineers. They can just do it on their own and have that data updated automatically along these regular collections. So it's about, again, rapid access to data and definition of correctness through that data. And lastly, talking about task automation. Again, if we have information, we can create guardrails around that automation, right? We have definitions of correctness that gives us the flexibility to either predict an outcome or to fail fast, right? If we make a change and then all of a sudden our rules and compliance are out of compliance, like whether it's reachability or isolation, we'll get that feedback. So we can quickly remediate either within that change window or come back, look at our data, and resolve it next time with context. It's about change window correctness, but it's also about assuring that you don't wake up to a bunch of phone calls on Monday morning after a big change. And on top of that, around that incident response, last ticket here, is that I want to know, okay, I have this host that was compromised. If I understand every possible permutation of traffic, where could it go? Who is next? You ask your incident response team now, what do? Well, they cut the cord to that device and they cross their fingers they didn't get anywhere else. It's not realistic for them to know all of the places it could touch on all of the different protocols. So this is effectively looking for that one IP address. It'll tell you the port it's connected to, tell you its first hop gateway, and then it'll also tell you tabularly all the different destinations, different hosts that individual host could reach on what ports and protocols. So if it is a mailworm or a SQL bug, we know exactly which ones to take a closer look at. But this is just scratching the surface. There's a lot of different use cases for digital twin for your network. I encourage you to come see more. I'm right over there. If you have any questions or comments or want to try to prove me wrong, please stop on by. I'd love to have a chance to speak with you. Any questions? All right, well, thanks so much for your time. I appreciate it. All right, take care.